All right. So this brings us to the second part of tonight's session. I just wanted to touch base on something that Tony said, and he said that obviously, we're a group of females, and one of the targets is to sort of build lifelong relationships. And I'm actually really pleased to announce that the next two speakers are now my dear friends and colleagues. So yeah, definitely a huge benefit of the centre. So yeah, thanks Tony for setting those things up as well, and giving us the opportunity. So Xuejiao is a PhD candidate at Flinders University. She's working with Professor Colin Raston's lab, where she focuses on the application of the vortex fluidic device to drive sustainable innovation in organic cosmetics. Her research has led to the development of energy efficient one-step processes for producing high performance cosmetic ingredients with multifunctional properties, including antibacterial activity and enhanced formulation stability, in all alignment with green chemistry principles. Xuejiao has published several peer-reviewed articles on this topic in Q1 journals and continues to contribute to the field through scientific presentations and active engagement in industry collaborations during her PhD. As part of the ARC Training Centre for Green Chemistry and Manufacturing, she has gained valuable hands-on experience with industry partners and benefited from the centre's strong academic industry network, technical training and collaborative research environment. Outside of her academic work, Xuejiao is passionate about playing guitar, dancing, hiking and camping in her free time. I can also attest to Xuejiao's knowledge, as I've definitely called upon it more often than not. So thanks, Xuejiao. Over to you.
Thanks, Adele. Can I share my screen now?
Yeah.
Okay, thank you. Thanks, Adele, for introduction. Thanks, everyone. It's a great opportunity for me to introduce my research with anyone who is interested in green chemistry. I'm Xuejiao Cao. You can also call me Sarah. I'm a PhD student from Flinders University and under the supervision of Professor Colin Raston and Professor Yu Hongtang. My PhD project is about vortex fluidic technology for sustainable innovation in organic cosmetics. So when talking about cosmetic, everybody can feel connected. The shampoo, hair conditioner, the moisturizer, everything we use in any single day. However, traditional cosmetic has high proportion of synthetic chemicals, which not only can cause skin issue like redness, irritation, sensitive skin, also cause environmental pollution. Nowadays, the public pay more attention about the products they apply on the skin and hair, and also the good education encourage people to take more responsibility in environmental protection. So both public and industry has more interest in nature-based cosmetic products. It's reported that the market of organic cosmetic reached to $22 billion in 2024, and will increase to $35 billion in next 10 years. This booming market also come along with more and more international recognized cosmetic standards. It keep integrity and the quality of our products. What's more, in their articles, they required the production of those ingredients has minimal molecule modification, be energy efficient, with environmental friendly method and hazardous chemical free. However, even the benefits for both our human being health and the environment, the development of a green methodology and a technology compatible with organic cosmetic remains limited. So in this background, what's more, those standards are great in line with UN Sustainable Development Goals and the green chemistry principles, especially in the circled point. So in this background, the vortex fluidic device can offer such sustainable methodology for producing ingredients for organic cosmetics. The VFD, the thin film technology, which utilizes the rapidly rotating tube to achieve efficient mixing and heat transfer. The design of this device is scalable and flexible, making it suitable for both research and industrial application. The previous publication helped us better understanding its working mechanism. There are two, as a thin film technology, there are two important technological fluid flow, the spinning top flow and the double helical flow, which can be tuned and changed by the rotational speed, the tube diameters, influenced by the liquid's viscosity, and other parameters. VFD has been extensively explored in the research area like carbon materials, biochemistry, energy production, liquids study, food science, like fish oil encapsulation, with more than 800 publications with good quality. Okay. So for my PhD project, we aim to develop sustainable research methods for organic cosmetic in practical industrial application. Collaborate with cosmetic industry, we undertake several projects like shampoo processing, the development of moisturizer, the production of natural insect repellent, and other cosmetic-related ingredients. In the past 3 years, our work is getting recognized by the public. For example, we have the publication highlighted in the ACS press pack. We have article published in the Chemistry Australia. Also, more details can also find in our Flinders website and other social media. They are great encouragement to continue our research in line with green chemistry. So in next few slides, I just briefly introduce some of our research. So one of the important projects we aims to produce the ingredient for cosmetic application. The first project is, sorry, I cannot see the screen. So the first project is about the production of fatty acid ester from vegetable oils. As illustrated in the graphic abstract, we aim to produce the FEE from vegetable oil using VFD. At room temperature, we can finish the efficient production in 20 minutes. And afterwards, we can apply those ingredients in emulsion to achieve its application. So with different oil, we try to optimize the production process. Also, we would use like the corn oil with high acid value and high proportion of carbon-carbon double bond to test the energy efficiency and process optimization efficiency. We hypothesis that the vortex fluidic technology can achieve efficient production for cosmetic application. So in our first step, with the help of the surface response surface methodology, we achieve the highest yield at the circled parameters. In this step, we use the small standard of VFD, which only required for about 2 milliliter liquids to finish the processing, which we can just avoid excessive material waste. So after the optimization, we try to scale up its production, utilize the upsized VFD to make it suitable for industrial application. After the series of characterization like NMR and FTIR and GCMS, we can make a conclusion that with the higher speed of VFD processing, it has higher FAE conversion. Besides, the VFD, which can achieve efficient production at room temperature, has significant higher yield FEE than the one we achieve via the benchtop method, which processed at 70 degrees. Also, it has better preserved carbon-carbon double bonds, which can achieve efficiency production. So we continue the characterization. The NMR spectrum, GCMS spectrum also confirmed the purity and the efficient conversion of our products from VFD processing. As we can check here, with VFD, there is no residue structure from the triglyceride structure. However, the traditional method cannot achieve completely conversion of the FEE from the original oil. So when talking about its realistic application of our ingredient, we need to consider several properties of those products. Is this too greasy when applied on our skin or hair? Does it have good spreadability when just you apply it on your skin surface or hair surface? Does it stable enough during the storage? So with the help of scientific technology, we can make a conclusion that with our FEE-based emulsion, we have smaller particle size compared with oil-based one. It has more uniform distribution when we try to quantify and quantify the particle size via the DLS technology. Those properties can contribute to its improved thermal stability, as we can say there is no phase separation with FAE-based emulsion compared with original oil-based emulsion. So continued with our first project. In next one, we aim to apply the green-produced FAE in hair protection. As illustrated in my graphic abstract, our hair suffer from excessive sunlight exposure, excessive heating process, usually fragile and have damaged cuticle. So in this study, we just aims to improve its lookings and as well as its integrity. So after the cleaning production of the manganese FAE, we try to apply them in our hair surface to check its morphology and integrity. So the most outstanding part is it's about its morphology. According to the SEM images, we can notice that the FAE can achieve very uniform and contact film coating on hair surface compared with oil coated one. We can also notice that the original hair, after excessive heating process, they have too much cracks on hair surface. Besides, on the BET test, our hair treated by the manganese FAE has much smaller particle size. Besides, the product has better coating efficiency. We can notice that with this coating material, there are only less 101% of nitrogen and sulfur on hair surface, which can indicate that the material can have good spreadability and can very uniform distribute around the hair surface, achieve the hair protection efficiency. So also we try to use the scientific methodology to further quantify and quantify its protection on hair surface. So with the help of the dark field microscope, we can notice that the hair treated with manganese FAE has increased hair growth. Also, the FTIR indicates the hair suffer just to have less oxidation degrees after sunlight exposures. The good spreadability and good looking on hair surface also indicates the success of the application of our products in hair protection. So the What's more, we try to improve the shampoo stability by spinning it in a WebD to achieve the improvements in both stability and cleaning efficiency. So we can notice from the morphology picture, there's no phase separation of the WebD processed shampoo compared with original shampoo. This benefits from the mechanical energy of WebD processing, which can uniform distribute the glass sphere into viscous shampoo to significantly improve its homogeneity and uniformity, avoid phase separation caused by gravity and other factors. What's more, in our foam stability, it has improved foam stability and better hair cleaning efficiency. So because our time limitation, I just brief introduce some our ongoing projects, like we try to develop the natural antibacterial agent or the natural fragrance for its sensory application and antibacterial application. Also, we aim to produce the tone oil-based polymer for hair tensile improvements. In short, all of our projects aims to produce and process organic cosmetics, aligning with green chemistry principles and sustainability. I think my research is also get benefits from my hands-on experience from the industry. We have the company. We have collaboration with a cosmetic company located in Adelaide. We can go to the raw material like the butter, all kinds of moisturizer, the hair samples. It's very convenient for us to continue our research. Besides, I try to do some casual job in the factory, making shampoo and record the stability. Also, our fluoride regular meeting. Fluoride regular meeting help us better understand how we can apply the scientific technology for realistic application. So, as a member in the Green Chemistry Center, I got tremendous support and training sections from ARC Green Chemistry Center. For me, the ARC Green Chemistry Center is more like a family, providing us the research training, the green chemistry insight, the collaboration opportunities, also provide us supportive environment and try to help me to get more confidence and positivity. Like we have the workshop in Melbourne and Adelaide in 2023 and 2024. We have green chemistry conference to make connections with scientists. Also in February of this year, we can just catch up with scientists from all over the world to communicate our research and introduce our research group and learn something new. As a part of the center, we also try to promote the green chemistry to the year 9 students in Flinders University, which aims to inspire the young generation by showing the principles of potential green chemistry. It also benefits me so much because I can understand the principles, the meaning of the green chemistry education better by demonstrating with my colleagues. I just very appreciate everything in the ARC Center and very appreciate the opportunity we can have some hands-on experience in Flinders. So that's all about my research introduction. Thanks everyone for your patience and your listening. Thank you.